Okay, so we will continue with the PHS 2021 paper for the 4E Pure Science. Okay, this video will cover most likely, let me see, question 3 and 4. Okay, so question 3 is your standard vector diagram drawing. So for vector diagram drawing, first thing you need to ask yourself is there a net force or a resultant force? So here you can see that I have actually highlighted to you. If you see that the object is just hanging over there, most likely it means that it is in equilibrium and that there is actually no net force. So in your entire vector diagram, I shouldn't be seeing any double arrow. So now check your answer. If you see that there's a double arrow, highlight it, it will be marks deducted. Now when it says that it is at equilibrium, it also means that the vector diagram that you are drawing should be a closed triangle, meaning that the arrows should flow in one direction only. Okay, next thing, what you need to do is to construct the bearing first. Once you construct the bearing, you can identify the direction each vector is going. So what do I mean by vector? So here I can see that there are actually three vectors. Vector number 1 will be T1. I do not know its magnitude, but I already know that it makes an angle 30 degrees from the horizontal. So horizontal refer to this line, the bearing, the flat line there. Then the other vector will be the green one, which is T2. I also do not know its magnitude, the length, but I know that it will make a 60-degree angle with the horizontal and towards the northeast. The third vector is actually not shown here, but it is actually the weight. So maybe I use green to show. So this is your weight, and the weight is given as 2 Newton. So now I know that this thing, it is being hanged there, meaning that the three vectors T1, T2 and W will form a closed triangle. So obviously the easiest one to draw would be the pink one, which is my weight. So I know that it is going down, right? So I will put my starting bearing at the top. So I will call it the start. Okay, it is just my habit because I tend to forget things as it goes along. So I will draw the weight. I will make it 2 Newton. So obviously you should set up your scale. How many cm is to how many Newton? You need to have this. Once you have that, you can then draw your weight. So make sure that it is long enough. So for example, since I'm using 2 Newton, maybe I will use 1 cm for 0.5 Newton so that this line is around 4 cm. It is long enough for me. Now once I finish drawing the first vector, I will also put a bearing at the end. Okay, this will facilitate me drawing the next vector. So the next vector, I can draw either T1 or I can draw T2. So maybe I will just follow the sequence and I will draw T1 first. But then I realize, if I draw T1 actually goes to the northwest. And if I draw T1 first towards the northwest, I would find that there is actually not enough space. So because of that, maybe I don't draw T1 first, I will draw T2 first because T2 goes to the northeast. So it is going to northeast at 60 degrees to the horizontal. So this is my horizontal. I will use my projector and I will measure 60 degree, right? And I know that my T2 is going northeast at 60 degrees. So what I will do is that I do not know when will it end. So I will just use dotted line, dot, 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 dot. So this is my T2. I do not know where we will end. But what I know is it will be at 60 degree. Now, if I do not know when will T2 end, I cannot start drawing my T1 because I do not know where should it begin. Should I begin here? Should I begin here? Or should I begin here? I do not know. So because of that, I find that I cannot draw T1 at the start. I have to draw T1 from the end. Now, what do I mean? Normally when we draw a vector diagram, we'll draw first vector, and then after that we will draw the second vector, and then if I know when will the second vector end, I will draw the last vector, right? Sometimes this last vector will point at, and it will end here, and this means that I would have a net force, right? But in this case, I know that I do not have a net force. I do not have a net force. This means that my third vector must start from the second vector and end right at the starting point. This is what we mean by a closed triangle. This means that my T1 must end at the start. So although I do not know where I can start drawing my T1, but I know that my T1 must come back to the start. So actually I can draw my T1 from the end. So this is my T1. If let's say this is the end, I would notice that my T1 will end at an angle 30 degrees from the horizontal. So what I'm going to do is that from the end, I am going to measure 30 degrees from the horizontal, just like this. Okay, and once I draw that, although I do not know how long I should draw, I can just sketch out that T1 will be along this line. Now once I do that, I will see that I have an intersection. Now what does this mean? This means that my T2 must end here so that my T1 can start at this point and end at where I start. End at where I start. Right, so this is my T1, this is my T2, and from here I will be able to find out the magnitude of T2 based on my scale and the magnitude of T1 based on my scale. Now take note that when I draw T2, it is always pointing northeast at 60 degrees, which is the same here. Point northeast and 60 degrees, right? You can see that the yellow and the green one actually match. Right? Similarly, when I draw my T1, it will end at 30 degrees towards the northwest. Right? So you can see here, 30 degrees towards the northwest. Okay? So that is your vector diagram. Now moving on to question 4. Question 4 is basically your very standard barometer kind of question. Now sometimes barometer is designed this way, where there is an opening, right? If you see that a barometer with opening and then this side connected to a certain gas supply, then please take note, the pressure of the gas supply, which is here, pressure of the gas supply, will be equals to the pressure at B, which is here, and this pressure at B consists of the pressure from this column plus the atmospheric pressure. So we can write pressure of gas is equals to pressure of the column plus pressure of the atmosphere. But in this question, they actually close the other end of the barometer. As you can see, they are different here. And in this closed barometer, there is nothing inside. So there's vacuum, space, nothingness. So there's no air molecule knocking onto any of the surface, so therefore the pressure there at the yellow part, it is 0. So in another word, when you want to form your pressure equation, pressure at B equals to pressure at A, you do not need to take into account the atmospheric pressure. Now that's one. Number 2 is, you also notice that in this diagram, the height is given in cm. This is not the SI unit for height. So you need to pay attention, and therefore you see a star. Next thing, what is inside is actually not mercury, but alcohol. Now if it is alcohol, then you cannot use a unit like cmHg, because Hg stands for mercury. So meaning that actually this question is very straightforward. You just need to use your ρgh formula. Define pressure, please go and look at the book. I think it is something along the line that says pressure is the product of blah 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 blah. So this one you go and figure out. Okay, for your part B, like I said, it is pressure at B equals to pressure at A. Then after that, ask yourself what consists of pressure at B, which is just the pressure of the gas. And for your part A, because on top is a vacuum, you will only have column on this side. So down here, I have highlighted to you that it is a vacuum. So once you have that, you can just turn the pressure of a column to rho GH. Like I said, in physics now, you do not, you do your equation left hand side, right hand side, up to down. Okay, it is no longer like last time you do like left side fixed and then right side, right side, right side. It's not like that. So once you know this is rho GH, like I said, be very careful. The H, you must turn it into meters. Okay, and then after that, this will be your answer. Now, in some cases, they may also change the unit for your density. So in this case, do check your density that it is in SI unit. If not, you will need to do some conversion. Okay, for your part C, basically they want to change the alcohol into water. So down here, you will see that the starting expression is almost the same. Instead of alcohol column, now you have water column. So down here, the only thing that changes is actually the density of water over here. And down here, you will notice that I put delta H, which stands for the height difference. So down here, you can see, yeah, I'm also using the height difference on top. So I find that if I use water, my height difference will be 0.48 meter. I find that meter is a bit hard to visualize. So I actually, in my mind, I turn it into cm, which makes it easier. After that, you can just use any dummy value, but make sure that your differences is 48 cm and you'll be fine. Okay, last question over here is your standard kinetic model of matter question. They are asking you what will happen if the temperature drop and they want to focus on the change in pressure. So it's a standard model. Temperature drop, the speed, comment on the speed of the gas molecule, not the gas itself. Okay, you may want to, you can also use the term gas particle, is fine. Then after that, comment on both the collision force and collision frequency, because down here, once temperature change, both of them will change. Okay, in some cases, collision force doesn't change. I warn you first, it's not always together. So once you mention collision, you must identify to me what collide with what. So in this case, it will be the gas molecule with the wall. And of course, because now the molecules are moving slower, the collision force and frequency will actually drops. Finally, please quote the formula for pressure. In our case, the F will drop, area is constant, so therefore pressure drops. So this is 3 marks for you, almost like a giveaway. Okay.